Ladies and gentlemen. All right. I'm just going to speak here. So welcome to our next session. I'm going to be a poor introducer because I don't have any information about our lovely presenters, but we'll give them about 20 minutes each, and then we'll have a Q&A, and enjoy.
Good afternoon. I'm Neda Nazemi. I'm a PhD student at University of Virginia, and I specifically work on alternative water governance scenarios for water-scarce region. Specifically, I focus on Middle East and North Africa. You all know that water is a very limited resource in MENA region, and however, this region has around 6.4% of world population and around 4% of land area. Its share of total available fresh water is only 1%. And population of this region is increasing very fast. So just during the last 75 years, it has increased by 500%. So that means that the available water per capita is declining even faster. And it's also projected to decline to 500 cubic meter per year, which based on Falker-Mark scarcity index, it means absolute scarcity. So actually all of these countries in this region are dealing with a specific situation of minimum precipitation and maximum variability, both temporal and spatial. You can see all of these countries are located in this corner, which means that precipitation is very low, variability is very high. It can be translated to a frequent episode of drought. And climate change implication also has made this situation even worse. So now we have longer episode of drought and more frequent one. So yeah, we have a region with minimum precipitation, maximum variability, climate change, population growth, and the result is this. Almost all of the surface water in this region are affected greatly by this water crisis. Many of them already dried out completely, and also groundwater tables are declining very fast due to the overexploitation, which means that more land subsidence, more soil degradation, and also severe groundwater contamination. And these are just ecological implication. People in this area are suffering by this water crisis situation, especially the farmers in rural communities. They are actually the most affected communities because for many of them, farming is the sole source of income, and they are losing their job, they are losing even their source of drinking water, and they have to displace to other areas. In terms of water conflicts, it's at highest level ever at both international and national level. This is because that all of these countries in this region are greatly dependent on transboundary water resources. So when the water is limited, each of these countries are trying more to harness all of these boundary waters, which actually add more volatility and instability to this already unstable region. Let's look at the pattern of water consumption in this area. As you see, on average, around 85% of the whole available water is used for farming. And this is huge in compared to industry sector and also residential sector, which actually kind of give this idea that agricultural water demand management is the most challenging problem in this region. And the reason that is such challenging problem is that this is a kind of multivariable problem with a lot of interconnections, with a lot of different stakeholders and different interests and values. For example, I just give an example of the complexity of this problem. Actually, the most important trade-off in this problem is a balance between food security and water security, which actually all of these countries have to decide which one they want to compromise more. So also we have a high uncertainty in this problem. We even here in US, in DC, in White House, I don't know where is it. We don't have a consensus over climate change implications. So yeah, we have huge uncertainty and also a huge knowledge constraint. That's actually makes us dare to call this problem a wicked problem, a term that Rittel and Weber started to use by early 70s for some social planning problems, which means that there is no concrete, straightforward solution for this kind of problems. If we look at the current governance regimes in this region, to see how they are dealing with this wicked problem, we will see that they are mostly centralized, top-down, inflexible, and over-focused on supply augmentation. In parentheses, I just want to mention that I believe that this attitude has borrowed from a kind of classic Western development paradigm, which actually changed what farmers in this area had been learned for thousands of years. Because all of this nation has been survived for several thousand years without building dams or water diversion tunnels. Actually, this paradigm taught these farmers that water is not a limiting factor. You can overcome nature limitation. No matter how down the groundwater table goes, who cares? We can dig deeper and pump the water. So yeah, this is, I think, that the dominant approach in all of the MENA. Our friends in last session also talk about that, how entitled people feel that that they never just go for water demand management. And also they are very indifferent to ecological sustainability of this region. And I think that as Western development paradigm has learned his lesson, and it's modifying itself by searching for more adaptive governance scenario. Here in MENA, also water governance should actually change their attitude to more adaptive, more sustainable governance scenario. And this is exactly the question that I'm going to ask in this research, that what are the alternatives governance scenario, and which one can better guide these countries toward a comprehensive sustainability. So my objective is to construct or build a few alternative scenarios that are highly plausible, and they are systematically different, and also they are kind of normative, which can address agricultural water demand management and also ecological and socioeconomic sustainability. This is the watershed that I chose for as my case study in this research. This is a watershed in central part of Iran. In terms of a scale, it is like Potomac River watershed. It's close to that. And with 5 million residents, 1 million are on farming as their income, and 300,000 are employed in heavy industries along this river. This river actually passes through this city, Isfahan city. Kind of, that this is actually the hub of tourism of Iran. It is a very ancient city, so beautiful, and after passing through this city, it actually ends in a wetland called Gafkhoni Marsh. This wetland actually is a preserved site by Ramsar Convention in 1974. So Iran is committed to guarantee the water rights of this wetland. All of this reason make this watershed a most strategic watershed in Iran and one of the most controversial one in the region. This watershed has been experiencing several long periods of droughts in last 2 decades. It already lost 30% of its runoff, and while the demand is always increasing because the population in this watershed is increasing very fast because it's an industrial and also tourism city. So many of rural area population are just moving to this city, and already 92% of the whole water in this watershed used in agriculture sector. However, it cannot satisfy the huge demand for agriculture water in this region. So, during the last 2 decades, 3 or 4 divergent tunnels, huge divergent tunnels, has built to actually divert water from vicinity watersheds to this one to satisfy the increasing demand. But it has not helped a lot, and now many of downstream farmers are not receiving their water rights, and there are a lot of protests ongoing during the last couple of months. This one, I hope that I can show you. Oh. Okay. I don't know why the link is not working, but I just wanted to show one of these protests that is really, really crowded by farmers, which was actually for last week. So to actually construct these alternative scenarios, I adopted a methodology which actually invented by Professor Tietje and also Professor Vieck in ASU University. It is a stepwise methodology and also a participatory one. So we got help from stakeholders in this watershed to identify which variables, which policies can help to better manage the agricultural water demand in this basin. And also we performed several different type of analysis on these variables. We performed impact analysis to find out the key interconnection between these variables, and also we perform consistency analysis to make sure that our scenario or selected scenario are plausible enough. And also we perform the diversity analysis to make sure that our selected scenario are different enough, they are distinctive enough. And then we interpret this scenario and let our participant again give us feedback about them and evaluate them with their help. This is the statistic result of my analysis. As you can see, my selected scenario shows a good consistency. You can see that there is no, the number of inconsistencies is 0 for all of them. And also, this shows that this distance between each scenario from the harmonic mean of other scenarios. So it shows that all of my scenarios are kind of evenly distributed. So I don't want to bother you with more methodology. If you have, I will be happy to answer any technical question that you have. But I just wanted to give you an idea about what these scenarios look like. This is my first scenario, which is kind of more or less the continuance of this current governance regime in this watershed. The essence of this scenario is food self-sufficiency, as now the Iranian government has such principle guideline to make sure that they at least they are independent in terms of staple crops. It's very important because they feel that they are not politically stable and they want to just have all of their food production domestic. This is a principal guideline. So to fulfill this objective, farmers are fully subsidized for water and energy, and they are also building another 2 diversion tunnel to bring more water from the other watershed to this watershed, and there is no ecological concern at all. So as a result, we can say that in 2030, we expect that this wetland is not receiving any water yet, and also we have an unproductive, inefficient agriculture sector because they don't pay for neither water or energy, and also because they don't care about safe yield, we expect to have more unauthorized extraction of water. And finally, we expect that we have more water demand for agriculture, which cannot satisfy. The second scenario that I selected, the second scenario that I selected is actually based on this idea, the economist idea of cost benefit, simple cost benefit, which says that if you price water, then this sector have to get more productive and efficient. So in this scenario, government is very small. It just prices the water and makes sure that water is allocated fairly among the farmers. And we expect that, and actually another essential essence of this scenario is that there are effective water markets that farmers can exchange their water rights. So we expect that under this scenario, many of farmers cannot continue, many of small farmers that have traditional agriculture practice, they cannot survive. They have to just trade their water rights and live there. I actually use some imagery. Maybe they are, I don't want to bother you with all of these systemic diagrams. So you can say, yeah, we have water markets. We have free trade, food trade. So there is no concern for self-sufficiency. They can import as much as water that as much as food that they want. And also water is priced. And so we expect that after 10, 15 years, we have more water productive farms that are actually producing a product like saffron that is not water intense, or we have very high-tech farms that they are very water efficient, but in many of villages and rural area are abandoned because they cannot continue a traditional farming crop farming, and they have to just trade their water and leave their homes. And this is the third one. I just show you the imagery because I think that I'm running out of time. In this scenario, this scenario is actually kind of extension of current scenario in this region. And still, food self-sufficiency is the principal guideline for government. But they actually have a national integrated planning in which dictate all farmers to what to cultivate, how much you cultivate, what kind of seed you use, which is more productive seeds. Or so under this scenario, I expect to have more industrialized farm, because they are, and also they are instead of subsidizing without any objective, they actually subsidize just farms that are water productive. So we expect that under this like scenario, we still have no like ecological sustainability because it is not the concern of like water governors. And also, I believe that under this scenario, there is a huge responsibility on the water governors. So I believe that the water conflicts won't like eliminate totally because the expectation of farmers will goes higher. And yeah, I think that I don't have like enough. If I can I get just 1 minute to finish? Because this is actually, I kept the best piece for last. This is my best scenario. I love it. In this scenario, actually, it's kind of like return to old time. I just want to explain that there is a huge knowledge in local farmers, which actually they learned like in thousands of years of practice, and they just lost it over like this Western like development paradigm. So the government in this scenario is just responsible to support the farmers to actually to make sure that water is allocated based on the traditional water rights, and also support the rural communities to shift from from farming to less water intense businesses. So we can see that under this scenario, we expect to have more like rural businesses growing, and also we have like farmers market, we have like rural festivals, and also this is totally based on local governance. So sorry. And this is the summary of this result, and I think that I don't have enough time to wrap it up. So okay, I just one point that I want to say, that if you look at this summary, you will notice that actually food self-sufficiency cannot happen even under the first and third scenario, that the principle of our guideline is self-sufficiency. Food self-sufficiency cannot happen because the water is limited. And so it is, if I just want to just give one takeaway to policymakers in this area, I will tell them that, okay, you cannot be self-sufficient under any like circumstances. Thank you. Sorry that it's.
Okay. So I'll give myself a short introduction. My name is Richard Rushforth. I'm an assistant research professor at Northern Arizona University in the School of Informatics, Computing, and Cyber Systems, which I admit is a very weird department for me to be in. I'm not an informaticist or a computer scientist by training. I'm come from a background of soil science and environmental modeling, and I've just kind of found myself over the years becoming more and more an informaticist, and found my way into this department. So I'll be presenting some work that I've been doing at the global scale with some applications down to river basins. And my main area of work that I work in right now is big data modeling of food, energy, water systems. So goal of my main research project right now is to estimate global flows of food, energy, and water at the mesoscale, so roughly the US county scale around the world, and looking at direct flows of food, energy, and water, and also embedded flows of carbon, water, and criteria air pollutants. So as far as the research agenda goes, it's pretty narrow, I would say. But that was a joke, actually. It's way too broad. I'll go into the outline of this talk, some introduction and motivation. What we want to do is I want to posit this idea of rethinking how we think of river basins, which I think is a nice complement to Neda's talk, and want to argue that we need to expand our thinking of what a river basin is and how it interacts with the world beyond just the physical boundaries of the watershed at whatever scale you're looking at. And so with that and rethinking of these river basins, I'm going to introduce this concept and this methodology to conceptualize river basins as multiplex networks or multi-level layer networks with interactions within each network, within that network and across layers. And this kind of abstract, I'll have some visuals to kind of show what I mean by this. And with that, I'll have a short case study of how we can use this methodology to look at alternative water governance scenarios and further applications. And so some of the background and motivation, where I'm at in the world is a very water scarce area. We heard in the previous session about water buffers around 48 hours. The town that I live in right now has a water buffer about 44 hours. So if there's any disruption to the local water system, we have about 44 hours of potable water, and if not, if you're there for any longer, it's either bottled water or go to Phoenix, which is going from scarcity to more scarcity. And so this motivation of living in an area of scarcity and recognizing the scarcity is more and more what water managers are doing, not necessarily managing the physical water resource itself, although that's a very important component of their job. It's actually managing the scarcity of that water. So looking at water portfolios as a bundle of water resources that have different aspects of scarcity, resilience, vulnerability to each of them. So looking, instead of water is just a gallon or of water, looking at a bundle of resources that have embedded goods and costs to it. And then another motivation, and this is kind of a personal motivation, you know, if you're looking at research trends, there was at one point a water for energy trend in the research, in the literature, water for power, water for people, water for environment. And my argument here is that if we start looking at water policy paradigms in these very siloed approaches, water for energy, water for people, water for environment, we get very siloed solutions. And so I want to look at ways to synthesize these various movements in water policy into more of a holistic methodology. And the last one is that river basins have multiple boundaries. The one that we're most familiar with is the watershed boundary, whether it's a global continental watershed down to a regional watershed like the watershed that was just presented. So there are these physical boundaries of the watershed, but there are also the socio-hydrological boundaries. So if you're in a watershed that has water transfers, the actual water basin of that river basin is larger than the physical river basin because the water is being transferred outside of the basin, effectively extending the natural boundaries of the river basin. So to effectively manage these water resources, we have to recognize that we're not just dealing with the physical watershed, the snowpack over here, the watershed over here, but we're also looking at all of the specific human and economic uses within that river basin that export water outside of that basin, whether directly through canals and aqueducts or indirectly through virtual water. Oops. And so why focus on river basins? The obvious one, coming from a hydrological standpoint, is it's kind of like this basic unit within water resources. And we have to go beyond a traditional hydrological approach to this river basin and look at these coupled natural human systems within river basins, how they couple, how many are there. You know, there's ecosystems, there's humans, there's economic uses. There's multiple different coupled natural human systems that are operating independently and interdependently within a river basin. And then, like I said previously, the human boundary of a river basin is not necessarily the same as the physical boundary of the river basin. And so with this kind of background, I want to present some challenges to how we think about alternative water governance scenario, evaluating alternative water governance scenarios at the river basin level. Is how do we better incorporate cross-sectoral water dependencies? How do we formalize all the different uses for water, the stakeholders and the policies that occur within a river basin? How do we recognize the multiple, often nested boundaries within a river basin? And can we develop true systems-based frameworks for river basins? Now, one thing that I've come across reading through the literature is everybody talks about we want to be system-based or systems-oriented. How do we actually formalize that into mathematics that we can actually model a system, a complex system within a river basin? It's a very challenging task, but I think it will provide fruitful insights in the coming years. What I'm proposing for this talk is using multiplex networks. Looking at river basins as networks has been around for decades. So easiest way to do that is looking at a physical watershed and developing a network from looking at the topology of it. You have your confluences being the nodes in the network, all your tributaries being the edges in the network. And from that, you can look at inflows and outflows within the network and develop network-based statistics on what are the most important parts of the river network as far as statistics like betweenness, centrality, or inflows and outflows. And I think this is a very appropriate model to build on top of these, build from looking at the multiple different types of networks that occur within a river basin. And so with this framework, starting from a network-based river model, how do we incorporate food, energy, and water layers into that? So one way, and there are multiple ways you can do this, and this is just one way that I'm proposing here, is adding on top of this physical river basin model, network model, is a network model of the legal and infrastructural water uses within a river basin. So often you have water coming down from snowpack down to the wetland at the end of the river. But along the way, there are dams, there are aqueducts, there are canals, there are laterals, there are river basin sharing agreements. So we have to incorporate that into a new layer in this network that addresses this part of the river basin. So a legal and infrastructural network. And then on top of that, there is a economic reallocation of water through virtual water. And so we have to then look at this water that's coming down from the snowpack to the ocean. It's being diverted by canals and river basin sharing agreements, and then incorporated into water-intensive goods and services and reallocated around the world. And so we need to incorporate that, I think, at a minimal level into our view of functioning within a river basin. And so within this, this makes a multiplex network, and you can extend this method and this framework as much as you want, but the goal is to keep it simple and flexible because there's only so many things that you can keep within working memory. And it's also flexible for scenario development, and it can be top-down or bottom-up. So I'm presenting top-down method. We're also working on bottom-up methods where we have citizen scientists mapping out food, energy, and water flows. And so an idea of what a multiplex network looks like, since I've said this word so many times, you have several layers of a network interconnected across layers. And so within this model of the river basin, we have layer 1 being a hydrologic river network, layer 2 being a legal and infrastructural river network, and layer 3 being the economic reallocation of that water through virtual water. And the edges within this model of a river basin would be flows of water. So it would be flows of water in the natural system, abstractions from the natural system into, by policy and infrastructure, and then reallocation of that water through virtual water. And so this is one way that we could look at it, where we have hydrologic network underpinning a legal infrastructural river network, which underpins an economic river network. Brief case study, and so this is a new methodology that we've been testing out of the Colorado River Basin. I know it's not Middle East and North Africa, but there are very striking similarities just from looking at the pictures of Oman in the last session and the Colorado River Basin. It's highly arid, and it's transboundary, and there are conflicts. And so what we've done in this methodology is developed a multi-boundary multiplex network where we have the physical watershed in purple, the socio-hydrological network, river basin in green, the flows of the river, which is in blue, flows of the legal river in red, and then I'll show the final result in a couple slides. But overall, what to take away from this overview of the river is that more areas with less water scarcity depend on areas with more water scarcity. And areas with economic power have benefited from policy when it was introduced, and that the impacts that the policy have interesting repercussions now. So looking at, just summarizing this river basin network into choropleth maps, the predominant flow of of water within the basin is obviously from the snowpack down to the watershed, but the primary flow of virtual water through the basin is actually within the basin. And there are some or within sub-basins, and there are some cross sub-basin flows. But what's interesting about this and why it's interesting to look at this from a multiplex perspective is that the areas that are the largest sources of virtual water within the basin are also the areas that are most vulnerable hydrologically and also the areas that are most vulnerable due to policy decisions. So in case of a shortage within the river basin, there has to be a dramatic reorganization of how the river basin operates on both a physical level, a legal level, and an economic level. And so just an idea of how complex these multiplex networks can look. This is the economic river network superimposed on top of the first image I showed. So other interesting applications and how we can use this looking at river basins. This is from a study that's in progress right now, but developed similar multiplex networks for oil and gas flows, global oil and gas flows. And then looking at if we induce disturbances within the network, where are we most vulnerable to those shocks and stresses? And so looking at gasoline, the way to read this graph, if there's a disturbance with any of these infrastructure modes, if the network is unaffected, the metric is closer to 1. If the network is affected, capacity is reduced, the metric is closer to 0. And so what we can see, there are different structures to different commodity networks, and if you look at if the trucking infrastructure is disrupted in gasoline networks, that has a huge effect on the capacity of the entire network. And if you look at pipeline in the oil network, that has the largest impact on disturbance from a shock or a stress. So this is a direct follow-on from the methodology presented previously, showing if we induce shocks and stresses into a river basin, using a multiplex framework, we can identify specific pressure points that are potential concerns and for shocks and stresses, and then develop adaptation and resilience policies to address those specific nodes that can create disturbance throughout the network. So I've presented a surface water-based method. what we have been working on and developing right now are groundwater-based conflict resolution games, and we've been looking at doing that with virtual reality. We had proposed doing that initially with physical models, but as you can imagine, it's not really easy to travel with aquariums filled with sand, and it's a lot of questions at customs. So we're looking at doing this with software-based VR, so that you can actually physically experience through some reality what alternative water governance scenarios mean and how they impact you. So there are challenges to this. Data is the biggest one, obviously, in an informatics department. So what I worry about is data. So accuracy, comparability, issues of non-stationarity, downscaling. These are all issues that present major challenges to implementing this and expanding this to different river basins. The data that we mostly get is of the formal water uses that get modeled. So incorporating informal uses, informal water networks, that is a real and difficult challenge. And so for the reasons above, this method's been piloted in Colorado River Basin, been applying this to the Rio Grande Basin, looking at transboundary river flows, and then expanding this to a couple other basins in the coming months. So parting thoughts, from what we found, this type of method and applying this logic and framework to river basins allows us to do some scenario-based data-driven analysis and understanding specific pressure points for adaptation in response to water shocks. Multiplex networks, though, are very complex and interdependent. So the kind of the pitfall of this and the trap that you don't want to get into is being seduced by the model and saying the model knows all. This is just a heuristic to understand conceptually what's happening within the river basin. These methods can be used to evaluate robustness and policy outcomes, and then it's also, it's a top-down approach that can complement bottom-up approaches. And then questions, comments? I think we're open for questions now. So I'd be happy to answer any.
Thank you, Richard, for an excellent talk. I just wondered, as a non-kind of mathematician, how do you, not in great detail, but how do you kind of map the virtual aspect if it's a mapping on a local scale, in that I imagine the virtual water would be actually going out at much larger circulation?
Yeah, so that's probably like an entire talk in and of itself. But that modeling involves global and subnational trade databases.
Okay.
And so with that, you kind of harmonize these subnational trade databases with global trade databases, so you can get intranational commodity flows and international commodity flows, and then harmonizing those data sets with agricultural data sets, power data sets, and then running a process of estimating irrigation withdrawals for agricultural use within each county, how that and then gets incorporated into a commodity flow network, how with water withdrawals for power production gets incorporated into a electricity grid. So it's there's a lot of data science underlying this.
Okay.
And that paper should be coming out soon in hydrological earth system sciences.
Okay, I just wondered because I didn't see it visualized on the local scale, so that was just my question.
Yeah, it's no oversight.
No, it's a big, thank you.
Sure. I have a question. Given the huge data constraint in developing regions like MENA region, how you can just adopt your methodology to this region with a lot of data constraint?
Yeah, so that's a good question. That's something that we've been kind of dealing with. So as far as the trade flow, looking at how things are moving between countries and within the region, Comtrade is a good data set for that. It gives a good idea of origin and destination flows and transflows between countries. But in addition to that, using remote monitoring data, remote sensing data, excuse me, to understand where agriculture is actually taking place within the landscape, and then from that understanding what those climate variables would be to estimate crop ET. And so then you can get a water budget for specific crops grown in a specific region, and then you just have to, this would be actually the hard part then, segregating that water consumption into the green water component, what's being provided by rainwater, and then what's being provided, the blue water component. So there's a variety of different methods that we could walk through that.
But it's possible.
Yeah, it's possible.
It's good news.
Yeah. I need a couple PhD students to do that. That's the bottleneck there. Hours.
The disturbance you put on the pressure points, is it simulation or you use another method?
It's simulation. So we damp down, we run through various scenarios, and we say, let's reduce capacity of, we want to maintain the total movement of the commodity within the network, but let's damp down, let's set the ability to truck some good around by 50%. What does that do to the network? Can you actually move all the goods around? And so it's kind of it's an evolutionary algorithm that kind of walks through that. And that work is actually done by my colleague, Jacopo Baggio, who is a mathematician. So
how does those simulation results really make implications on how to control and how to mitigate the consequences of such things?
Can you restate that?
mean,
Sorry.
The result of your simulation says, for example, if you reduce something by 15%, then you're gonna have some problems.
Yeah.
How you do find out the solutions for those problems? You come up with policies which can mitigate the consequences of those constraints.
Right. So that would be, we haven't crossed that bridge yet, so I can't give you an example, like a concrete example, but I think the solution there would be entirely place-based. So if you're looking at a river basin in one region of the world, and you identify one area could be a pressure point within the river basin, you'd have to evaluate all the factors that go into what could potentially make that area a pressure point. So then it gets down into this scenario-driven work that Neda is doing, and actually evaluating and being on the ground. So this tool isn't, let's say, for diagnosing and actually being on the ground and fixing the problem. It's for identifying where a potential problem could occur and then delving in there further. Because the idea is to screen out, and you don't have to look at all of the places all the time. You can say, this one is where we should be focusing. And then you could be wrong, and then you have to reformulate the model. And then, that's just an issue that I don't want to take up all the time for questions.
That's okay.
If Neda if there's any questions for Neda.
I actually have a question for you. I was wondering if you could talk a little bit. We had to rush you through the end of your presentation a little bit, but your third scenario with the more traditional methods, the farmers' older methods. If you could talk a little bit about what that meant, if there were any specifics about
Okay, sure.
those
Yeah.
processes.
This is actually the idea and the theme of this scenario is exactly rural development and local governance, which the local governance is what we used to have as a traditional water governance. It is a really well organized water governance system that these farmers used to have and they learned it from thousands of years of practice. And so we wanted to just recover this local governance that government or state, central government is not have a huge responsibility, and so that the locals can actually share the water and do all of this maintenance. Also the assigning responsibility between themselves and pay for the cost of operation of their system. So I believe that this is exactly, I don't know, in your session we were talking about entitlement. It is I think that is very important that why farmers now are such entitlement in this region in terms of water, and they do not have the understanding of water scarcity, because they haven't been like this forever. And so I think that it's a very good way to recover that and let them to decide for themselves. But the central government can support them in terms of helping them to start grow their local businesses. So it actually relieves some pressure from the water resources.
Yeah, my question is also related to that as well. Thank you for your talk, by the way. I was wondering how much, you said a lot of knowledge is being lost. I wonder, is there still some kind of knowledge about water management systems, traditional governance? And, for example, could the rehabilitation of qanat systems play a role in that, which supported the water infrastructure in Iran for thousands of years, right, until quite recently? And then have you thought about this relationship of locally kind of traditional systems in relation to the state, for example, either in participatory or polycentric kind of governance systems as a way for kind of recognition, or to allow that kind of local recognition, or at least some kind of decentralized governance to give them a sphere to actually both support but give them room to develop or redevelop those local systems?
That's a very good question, actually. Currently, 80%, I think, if I remember the number correctly, of these qanat networks are not working anymore. So yes, it's very hard to recover this traditional, and also but there are very good studies that actually try to recapture and also revive this the knowledge, at least make them in form of written. So because many of them are just oral knowledge between these families and troops, and this is many of them outstanding. You cannot believe how accurate is this traditional water governance system. I read a couple of papers and I was shocked. I just give you an example. For example, the people that dig these qanat networks, is very it used to be very dangerous job, because they were just digging tunnels underground, and it was very accurate tunnels that some of them are hundreds and some of them are thousands of kilometers, these tunnels, and it goes to exactly central desert of Iran from the mountainous area. It's wonderful. So it's very dangerous. So the local communities were responsible for these well diggers. I think 2 generation or 3 generation after each well digger were tax exempted. they do not pay taxes. And also these well diggers used to wear their, like, because you know Muslims, when they die they have to get washed and wear a white dress to like bury it. So they used to wear their white dresses when they go down, so they won't like put in danger other communities to if the tunnel like ruined on them, so nobody have to come down and take them out, and they buried itself. So it is just like one example, and this is like huge knowledge of, and it is all lost or not lost. It's going to be lost soon by this like new modernized governance system. Do you get your answer?
Yeah, and the polycentric aspect. I mean, I saw you used Ostrom to an extent, and she talks about, and with Vince Ostrom, about polycentric systems in terms of recognizing. Have you looked at that at all, or could that be useful in your research?
Yeah, definitely. It's very interesting, and no, I haven't thought about that. So yeah.
Or even the customary law aspect. Sometimes they have customary aspects of local management. So recognition in terms of legal frameworks or all sorts could be possibilities.
Yeah, that's very interesting. That would be very interesting.
I've got an article coming out on that soon, so I think.
Yeah, we can just conversation after that.
Can I ask about water efficient farming? You know, in America, in California, you know, they use a lot of water for farming, and they don't necessarily farm the things that produce. They farm the things that they can sell for a lot of money, but these things might use a heck of a lot of water, so they're not very efficient in terms of
water.
Is there a problem in Iran, you know, that the farming is not water efficient?
Exactly. That's wonderful question, because it's very hard to convince people, even sometimes academia, to differentiate between these terms. And you actually notice it, this problem that actually they confuse water productivity with economic productivity. And this is what that actually during maybe 10 years, all of investment to solve this water crisis, all of the investment was to make farms more efficient. But what do we mean by efficient? We mean that installing the high tech irrigation technology. But what happens? Actually, it get more economically efficient. But those farmers just grow more because they have enough land, but they don't have enough. The water is limiting factor, not land. So they just grow more, and at the end of the day, more water is consuming. So it is not definitely. We cannot say that it's maybe ecologically efficient. It's not. We have to differentiate between what is efficient for ecosystem, what is efficient for water resources, and what is efficient in terms of economic. And they actually started to a lot of investment on revolving farms to industrialize, to make them more efficient. But now a lot of studies shows that they are not. They actually doesn't help to solve this problem. Do you get your answer?
Great point.
Do you see any issues with water allocation in Iran? Like you were talking about the Qanat channels going for a long distance. So I wonder if that might have some boundary issues as it travels.
That's a very good question. I don't know how this operation, how they put boundaries for maintenance. I know that they used to be local in each community. There were representative, for water representative, but they call it mirab, and this person was chosen like by in a very democratic way, and they got like vote election, and I know that this representative used to actually negotiate with other like mirabs in other like communities. So they have like there's written like documents for how they share waters between themselves, and they respect that. Yeah.
Maybe on a related note, I was wondering how you represent the legislative framework in terms of your data points.
Yeah, so that's difficult, and one of the reasons we've only worked on specific river basins right now that have defined sharing agreements in place, and we know where water is being withdrawn through the legal and infrastructural system. So that's a huge challenge, because we have to be working in areas with this, the way that we have it formulated in this presentation. It has to be in a river basin that has defined sharing agreements and allocations. And so that it presents a whole host of problems, especially in areas where water use may not be regulated, there may not be a sharing agreement. Water use could be more on informal levels instead of formal levels. So there are a lot of limitations that come from a data-driven approach like this. So we have in the process of expanding it to the Rio Grande, and so that and the Rio Bravo. So then we can have both the U.S. side of the watershed and the Mexican side of the watershed, like we have in this study that has the Mexican side of the Colorado River, the Delta really, and then everything upstream. And so we get fortunate there where the Conagua and the Mexican equivalent to the USDA, I'm blanking on the name right now, they have really good data sets and irrigation district level data sets that show what crop is grown where, how many hectares, how many tons per hectare. And then Conagua has data on how much water is being used in each of the irrigation districts. And then there are some commodity flow data sets that do exist at the state level and at the federal level. So that it's a very good next river basin, but we're looking at expanding it off North America. One of the reasons in particular is looking at these international flows. With our data set, and this agrees with previous studies in the literature, the flow of virtual water from the US to roughly the MENA region is in the order of magnitude of 500 million cubic meters. So it's a huge amount of water, and it just depends on what country you are and what good you're accessing from the United States, what legal and or water policy you may be exposed to. So one area within the same continent may be more exposed to water vulnerability in the Ogallala Aquifer region because they access cereal grains from the Midwest. And so they're more exposed to that water vulnerability than, let's say, a different country that their main virtual water import from the US could be almonds from California. So vulnerability and where you're accessing goods from within a pretty large country makes a big difference. So we're working on all of those things. The answer didn't